In this tutorial we're going to be solving quadratic equations. So let's think of something like, well, let's have x squared plus, keep it quite straightforward to start with, x squared plus x equals 6. So how would we solve that? Well, there are basically two methods. I'm going to show you the first one, which would be completing the square. So this is when we if we draw a grid here, you don't have to do it by grid method, but I think drawing the grid shows you how this works and makes sense of what we mean by completing the square. Otherwise, people get puzzled about what that term means. It's simply that we're drawing a square here and we're going to complete it, and that's the method we use. Very traditional, very old method for solving a quadratic equation. Okay, and so the idea here is that this is an area. If we think of the x squared in our equation here, for example, that will go in here. Okay, and if that's the area of that square, then the sides of the square must be x and x squared. Okay, so you can see how this is going to go. We would then halve this x here, so we'd have half an x here and half an x there, and when we complete the square we would well, you can see we're going to end up with it. Let's just show you. So if we wrote plus a half, obviously the bit in here is going to be plus a quarter. Now fractions are fine, and we could resolve it using this method. You'll see where we're going with this in a minute. At the moment it won't be immediately obvious how this is going to help, but it will help enormously. What I'm going to do actually is change my numbers so I don't get these fractions, and it will look a lot nicer, and hopefully it will resolve slightly easier as well. So let's just reverse this, go back to where we were. Okay, keep our grid, and show you a little trick for making life a little easier. Okay, so one thing that I like to do when I've got something like this is think about this halving. If I'm going to halve this x term because of the two boxes that I've got, I don't really want to get into fractions, so I can, for example, multiply by 2. So then it would become 2x squared plus 2x on the left hand side, and on the right hand side multiplied by 2 would give us 12. I'm actually going to multiply by 4 because, again, I don't want anything unusual going on here. If I had 2x squared here, then it's going to be the square root of 2 on both sides of this square. So what I'm going to do is multiply by 4, and you'll see how this works out. So I'm going to rewrite this, multiplying both sides by 4, therefore 4x squared plus 4x, so multiplying both sides by 4, must equal 6 times 4, 24. Okay, so just multiplying both sides by 4 maintains the balance of the equation, so that's fine, but it makes our life a little easier. Okay, so now we go ahead and complete the square. 4x squared then in this box here, and then that must mean that we've got 2x here and here. Yeah, so that's the two sides of that little square there. Now, if we think about what goes here, well, 2x times something gives us x. In other words, 2x. Sorry, no, I haven't put this in, have I? Little mistake there. Okay, so that was because of the method that we went through just before. So what we've got to do is put in our 2x plus 2x. There we go. So that term splits into 2x plus 2x. I hope that's clear. Right, now, a lot easier. I've got plus 1 on each side now. 2x plus 1 times 2x plus 1 equals 4x squared plus 2x plus 2x. In other words, 4x squared plus 4x. But it equals 4x plus 4x plus 1. Why does it equal 4x squared plus 4x plus 1? Because I've got to complete the square. So if I just show you, here's my area that I complete to complete the square. There we go. And so my plus 1 term has to be added to get a perfect square. So I'm just going to add 1 to both sides. 4x squared plus 4x plus 1 equals 24 plus 1. In other words, 25. Do that straight away. Okay, now, why have I done this? What's all this rearranging done? How's this helped? Well, if I've got a perfect square on the left-hand side, never mind what I've got on the right-hand side, but if I've got a perfect square on the left-hand side, then I can rewrite it like this. 2x plus 1 squared. And that means later on, or just in just a moment, I'm going to take a square root, and then that will get me to my answer. Okay? So this is how completing the square works. On the right-hand side then, I've got 25. But 25 is what? Well, it's 5 squared. Okay? Or, and this is the important bit, minus 5 squared. And this is the bit where people can tend to go wrong. So if I'm square rooting both sides, I'm going to get 2 solutions. Now, you're going to get this wrong when you first start out doing this, and a lot of students do get it wrong who haven't sort of practiced or revised hard before their exam. They're going to get this wrong because they're going to forget that there's a negative solution, because minus 5 times minus 5. And I should put this in brackets actually, otherwise it doesn't mean that. Okay, minus 5 squared equals 25. They're going to forget that, but if after you've been doing this for a while, you don't forget it, because with a quadratic equation, you are expecting 2 solutions. Sometimes you only get 1 solution, sometimes there are no solutions, it can't be resolved. But most times you're going to get 2 answers, not 1 answer, whereas with a linear equation you're only going to get 1. So you are looking out for this, and so as long as you're reasonably practiced, you're not going to make this mistake. So what have we got here? We've got a square root operation here. So if we square root 2x plus 1 on this side, so let's just write that so we are clear what's going on. So we're going to square root both sides. The square root of 2x plus 1 squared is obviously just 2x plus 1. And on the other side, the square root of 5, the square root of 25 is obviously 5 or minus 5. Okay? So I've taken rather a long time to go through those steps, but hopefully it's clear why we're doing this and why this completing the square method works. Now all I've got to do is subtract 1 from both sides, so I end up with 2x plus 1 minus 1 eliminates that 1 equals 5 minus 1, or 2x equals minus 5 minus 1. And finally, to get my answers, all I need to do is divide through by 2. So divide both sides by 2. Let's just put divide by 2 so you can see what I'm doing here. So 2x divided by 2 is simply x, and 5 minus 1, in other words 4 divided by 2 is 2. Okay? Or we've got 2x divided by 2 is x equals minus 5 minus 1, so that's minus 6 divided by 2, in other words minus 3. Okay? Now, great, we've got our solutions, but was there another way of doing this? The other method, and it's a good method, is to use a quadratic formula. And that formula, if you remember from previous videos, is this: x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula. Now in the second part of the video we'll find out where that comes from and why that is true. But the first thing we've got to do, if we want to use the quadratic formula, is rearrange this equation in a slightly different way. And what we've got to do is put it equal to 0, because we need to have things in the form of a let's write it down here, a times x squared, so a number, a coefficient of x squared, plus bx, so coefficient of x, and the c in the equation, in the formula rather, is the constant at the end, and all of that equal to 0. So we have to have it in that form to be able to use the quadratic formula. So very easy to do. We just to change this to the right form, x squared plus x equals 6, minus 6, subtract 6 from both sides, and we'll get x squared plus x minus 6 on the left hand side, and on the right hand side 6 minus 6 equals 0. Okay, so I hope that's clear. But what we can do now is look very carefully at this and see that the a term is simply 1, the b term, the coefficient of x here, is 1, and the c term excuse me, is minus 6. So a is 1, b is 1, and c is minus 6. Now we simply plug those values into the formula, and it gives us the result. Here we go. X equals minus b, so that's minus 1. Okay, plus or minus, so here's where we're going to get two values, again two solutions. Square root of b squared, well b is just 1, so that's just 1 squared, minus 4 times 1, because a is 1, let's extend this a little, times minus 6. All over, this is sometimes what people forget, they forget the all over 2a, 2 and a is 1 times 1. But once we've done that, as long as we've done that carefully, I know it looks a bit horrendous, actually it's going to be a nice easy calculation and we'll get our answers very easily. So x equals minus 1 plus or minus the square root of whatever's under this square root sign. Okay, so we've got 1 minus 4 times 1 is just minus 4, so we can discount that. Minus 4 times, whoops, forgot the bracket there, minus 6, well that's plus 24, so it's actually 1 plus 24, in other words 25. Nice and straightforward. Divided by 2. And now, just to split this apart, we've got our two solutions, remember, so x must equal minus 1, either plus 5 divided by 2, or x equals, again, let's just join that together again. X equals, oops, sorry, it's a bit scruffy, but there we go, that's better. X equals minus 1 plus 5, oops, there we go, divided by 2. And therefore, x equals, well, minus 5 plus, minus 1 plus 5 is 4 divided by 2, 2, or x equals minus 1 plus 5. Where did I go wrong here? That should have been minus 5, shouldn't it? Okay. Let's just rub out this and start again. There we go. Minus 5, so it's minus 5, minus 1 minus 5 is minus 6, so that's minus 3 divided by, minus 6 divided by 2, it's minus 3. Okay, so pretty straightforward, both of these methods. They're quite involved, I suppose. They take a little bit of time, but both pretty reliably, as long as you're careful with them, produce these two solutions for a quadratic equation. Okay, let's do another one. Let's call that A then, and now we'll do problem B. Let's make it a little bit more challenging then. So we'll have a coefficient of x squared. Let's call it 4x squared. What should we have next? Again, let's make this a little tricky. If we put 3 as the coefficient of x, then we can't halve 3, so that immediately gives us a problem. Let's keep it simple from now on. Equals 1. Okay? So drawing our grid for the grid method, what are we going to end up with? We're going to end up with, well, if we put 4x squared in that top left-hand box there, that would be fine. But we've got this problem with the 3x, which if we split is going to give us an improper fraction of 3/2. I'd rather avoid that. We may get into fractions, but I want to, if I do, keep the fractions nice and simple if I can. So I might think about multiplying by 4. Well, that's going to make our numbers rather large. That would work out quite nicely, I think. But another strategy, and something that people sometimes automatically use without thinking about how they're going to do the problem, is simply to get rid of this coefficient here, the x squared coefficient, by dividing by 4. Let's try that and see how that works out. Okay, so we're going to use that method. We could have multiplied through by 4. We could have done it just like this and not altered the equation at all. But what I'm going to do is divide both sides by 4. Therefore, 4x squared divided by 4 is x squared, plus I'm going to have 3/4, 3/4 here. Okay, and divide the right hand side by 4 as well, so 1/4. Okay, so we're going to go with this and see if it works out. See, it might work out nicely, it might not. We'll see how it goes. X squared then goes in this box here, giving us our x times x on the outside. Now we've got to halve 3/4. Well, that's pretty straightforward. 3/4 halved is 3/8 of x in both these boxes here. And that must mean we've got to square x plus 3/8. So plus 3/8. So completing the square here, well, this does get us into quite a large fraction. So it's going to be 3/8 times 3/8 is going to be 3 times 3, 9, and 8 times 8, 64. So we've got 9/64. Okay. So that's completed the square, and now we know that we've got to add 9/64 to each side. So we say, we rewrite this x squared plus 3/4 x plus 9/64 now equals 1/4 plus 9/64. I think what I'll do straight away actually is just rewrite this. Well, let's just rewrite it now. No, let's use an eraser. Otherwise, it's going to look too complicated. I wouldn't normally use an eraser, but in the interest of space and I don't want you to look at this and think, gosh, that looks horrendous. I'm just going to change that quarter there. That's all I'm going to do. Okay. So 1/4. Well, it's 16. Okay, 16/64. And just checking, if you divide by top and bottom by 16, top divided by 16 is 1, and the bottom divided by 16 is 64. But I've multiplied it up here in order to add it to our 9/64. Okay, and immediately I can say, well, that's 25/64. Okay, 25. Let's make that clear. 25/64. Okay, what do we do now? Okay, we've got x plus 3/8, so we've done the difficult bit really. What we're going to do is the square rooting bit now. X plus 3/8 squared equals 25/64. Well, 25/64, square root of that is just going to be 5/8. But again, we've got to remember, let's just put in a square root sign, that every time we square root a number, like that, we're going to get a positive and a negative solution. Okay? So, that's where we're going to get our two answers. Okay, our two solutions to this quadratic, which is what we're expecting. So it's unlikely that we're going to make that mistake of forgetting that minus 5/8 is going to be one of the solutions, but well, worth remembering because a lot of people do make that mistake. Okay, so now square root both sides, and we've got what? X plus 3/8 equals 5/8 or minus 5/8. Okay, and if I subtract 3/8 from both sides, I'm going to end up with x. Either x equals 5/8 minus 3/8, in other words 2/8, or I'm going to get x equals minus 5 minus 3/8, in other words minus 8/8. And so here are my answers. X equals 2/8 simplifies to 1/4, or x equals simply minus 1. Good, so that's completing the square. Now what we're going to do is use the quadratic formula. Let's see how that works out. So rearranging first our equation, we end up with 4x squared plus 3x, subtracting 1 from both sides, so minus 1 equals 1 minus 1, 0. So that's the first thing to do. Now we're going to plug our a, b and c into the formula. Well, a is 4, b is 3, and c is minus 1. So x equals minus 3 plus or minus the square root of 3 squared minus 4 times 4, that's the a term, and now the c term, minus 1. Like that. And all of that, and here is something that can go wrong. It is easy to forget this 2a, so make sure you include that. 2 times a is 4, so 2 times 4. But once we've done that, if we've carefully plugged everything into all the parts of our quadratic formula, fairly automatic from now on, I hope. So x equals minus 3. Whoops, let's do that again. Okay, minus 3 plus or minus square root of 3 squared is 9, so let's write 9, minus, well, we've got a minus times a minus here, so it's going to be plus 4 times 4, in other words plus 16 all over 2 times 4, which is 8. Okay, I can just sort this out on the same line, I think, so I'm going to write minus 3 plus or minus the square root of 25 all over 8. And now we are going to move into our two solutions. So x equals, either x equals minus 3 plus 5 divided by 8, or x equals minus 3 minus 5 all over 8. In other words, x equals, let's write it properly, x equals minus 3 plus 5, that's 2/8, in other words 1/4, or x equals minus 3 minus 5, that's minus 8 over 8, so minus 1. So there you are. Two ways of solving a quadratic equation, a few variations as well within this completing the square method, but basically these are the two ways of doing it. Okay, but in the last part of this video, let's just have a look at this quadratic formula. Where does it come from? Well, we've already seen in the first part of the video that we start with the formula in this form, ax squared plus bx plus c equals 0. So it must be that we can rearrange this to form this formula, But how do we do that? Well, the answer is that we use completing the square. And we've already seen in the completing the square method that we don't want it in this format. We actually want to have it in the conventional format. In other words, we take the c over the other side. So if we subtract c from both sides, we'll get it ready for completing the square. So we then have ax squared plus bx plus c minus c just eliminates the c from that side, equals 0 minus c, so minus c. Now the other thing that we've already seen we have to do is we would have to divide through by a so that we remove the coefficient of x. Now we don't have to do that, there are other ways, but to rearrange the formula to get this equation, that's how we proceed. So let's divide through by a. So in other words, this has to be divided by a, which will eliminate that a. This has to be divided by a, so that's divided the left hand side by a, and the right hand side has to be divided by a as well. There we go. So we haven't done anything yet, we've just rearranged it ready for completing the square. Okay, and now we proceed. So we've seen that to complete the square, what we have to do, and I'll put it in parentheses because it's going to be a lot clearer, is we have to take our x squared term here, and then we look at our coefficient of x, and for completing the square we have to halve it. Okay, so we write plus b, so we could write half b over a x, instead of getting a bit complicated, it simplifies to b over x over 2a. So the dividing by 2 at the bottom is doing that halving for completing the square. Now what do we do next? Well, we want a perfect square on this left hand side. So we've got to take our b over 2a and square it. Okay, so we're going to add b squared, so this is the completing the square bit, this is the final quadrant of the square, b squared over, well, 2a squared is 4a squared. Okay, there we go. So looking a bit complicated, I know, but that's simply completing the square, and if I was to do this on a grid, you'd see how this works out. So let's just have a look at the grid. So if I just simply sketch out the grid like this, okay, here we've got, I'll use a different colour, make it maybe a little neater, you'll be able to see. Okay, so this is where our x squared would go in the grid. Alright, here we'd have our bx over 2a, so b over 2a x, b over 2a, whoops, x here as well. So when we complete the square, this bit here, we're going to have, well, if we do the outside, we must have x here and x here. We must have b over 2a there and there. So here's where we get our b squared plus 4a squared. So multiplying the top, b times b gives us our b squared, and 2a times 2a gives us our 4a squared. So I hope sort of visualizing it makes it clear what we're doing there. Okay, now let's just erase that so that that's not in the way, because we've only done so far the left hand side of the equation, but to balance the equation we're going to have to add that b squared over 4a squared to the right hand side as well. Okay, let's do it. And what I'll do is write it down straight away because it's a positive, so I can just put it up front here and subtract that c minus a. So there we are. All we've got to do is simplify this. And we've seen that if I remove the parentheses here, that'll be a lot clearer. We've seen that this expression here must be a perfect square. Okay. So we can write that in brackets. So we've got x squared, sorry, not x squared, because we're now writing the factors. So there we go. the factorized form. So we've got x plus b over 2a, which is one of our sides of our square. And so the other side is the same, so that gets squared. And that's the left-hand side now factorized. Okay? Perfect square. The right-hand side has to be square rooted. Now before we do that, let's combine these two terms. So here, b squared over 4a squared minus c over a. We need common denominators. So what have we got to do to get this to be common with that? We've got to multiply by 4a. So if we write this, let's just raise this. Well, it's just, okay, it's probably clearer if I do it like this. So let's just rewrite it. B squared, so this right hand side is b squared over 4a squared minus 4a squared, and we've multiplied that by 4a, so we must multiply the top by 4a as well, so we end up with 4a times c, 4ac. Okay, so we're getting there. Our right hand side now then is b squared minus 4ac all over 4a squared. But we can do something else. We can cancel, no we can't, sorry, nearly made a mistake there. We can't divide through by a very common mistake. We can't because there's an operator here. So that's as far as we can get with that. But what we're going to do now is square root both sides. So let's put the square root sign in. Okay, like that. Square root this side. Now if we square root this side, what you need to know is that square rooting all of that is the same as square rooting the top and square rooting the bottom. So we can write that like this. So we square the top like that, and we can square the bottom as well like that. So we separated these out, and that is the same as, well, 4a squared must be the same as 2a when it's rooted. So again we can rewrite that 2a, which has eliminated the radical, the root sign from the bottom. And here we go. We've got 2a, which is very similar now to what we've got in our formula. Okay, let's sort out this left hand side. So the square root of something squared is simply it, so x plus b over 2a like that equals the square root of b squared minus 4ac all over 2a. And now what we've got to do is subtract from both sides to leave the x on its own. So x equals square root of b squared minus 4a all over 2a minus b over 2a. So very nearly there. What we've got now is a common denominator. So this is how we get to the next stage, which is our final stage. We've got our square root of b squared. Let's give this a little bit more room. Okay. And in fact, what I'm going to do is rewrite it round the other way, because you can see where we're going here. So we're going to have minus, so we'll put this term up front, so we'll just commute these terms, minus b over 2a plus, well, plus or minus the square root here of b squared minus 4a all over 2a, and that is our common denominator. So if we put it all over 2a like this, we've got our quadratic formula. So a lot of quite complex rearranging, but as long as we know what we're aiming for, we're aiming to isolate the x, eventually we should arrive at x equals minus b plus or minus the square root of b squared minus 4a all over 2a. And as we've seen in the video, that's an extremely useful formula.